Hello everyone, in this video we'll be discussing lambda expressions or lambda functions. So why we need lambda functions is so that we have a small block of code that we will not be reusing, nor do we actually need to name it. It's just something we require for a one-time use. And so for that, instead of having to read or completely define a new function, we can quickly just make a lambda function out of it, execute whatever code we need, and get on with our day. So this is the syntax for a lambda function. We have square brackets within which there is the capture clause. Then we have the round brackets in which there are the parameters to that function, the arrow operator, and following which will be the return type, which that function returns. After the return type, there will be the curly brackets in which there will be the block of statements which we want to execute. Now, this capture clause is of three types. We capture by reference, we capture by value, or we do a specific or a mixed capture. And what are we actually capturing? We are capturing the variables which are in the scope in which the function is defined. For example, in my main function, I have two variables a and b. And while defining the function func1, I have a capture by reference. Now what this will do is that it will capture the variables a and b, or if I had another variable called int d is equal to 12, it will capture that as well by reference. So that is what the capture clause actually captures. And in case you don't actually mention anything over here, if it is like this, then what we'll do is the only variables this function can actually access will be the variables which are defined inside, which is the variables which will be local to this function. So within the curly braces, whatever variables you define, that will be the only variables that this function can access. So that was about capture clause. Now let's see this in action. So here I have a function called func1 in which it is equated to this lambda expression, and how I will call it is like this, func1, similar to how you'll call a function, but instead of having to actually define it like so, it won't be reusable in that case. Here it's just for a one-time use. I've quickly made up a function like this and assigned it to auto func1. So here how you actually define the capture clause is using this. So if I have the ampersand symbol, I'm accessing these values by reference, meaning any values, any changes that I make within this function to them will be reflected. If it is equal, then it will mean that I'm capturing them by value. So the values a, b, and d become read only, and I cannot actually modify them. We'll see that while compiling. And what I can do is I can leave it like this, in which I cannot actually access a and b within this block. I can only access integer c and whatever other integers are defined within my block of code, right? And we can also have a mixed capture in which a I'll be capturing by value and b I'll be capturing by reference. So in this way, b I will be able to change, but a will become read only, and I cannot actually make any changes to that. So now what I'm doing is I have this function func1 in which I'm capturing by reference, and then I'm calling let's actually do this for now. Then I'm calling that function func10. We see that it takes in an integer and returns an integer as well. So what I'll do is I'll just print out that integer. In my case, what I'm doing is I'm incrementing the value of these two local variables, or rather external local variables, by c, whatever integer I'm putting in, and I'm returning 100. So if I call func1 of 10, a and b should be incremented by 10, and I should have 100 printed since this function returns 100. So we see that func1 returns 100, which is 100, and then following which the values of a and b are actually 20 and 21, whereas initially I had initialized them with 10 and 11, meaning that they actually did get modified because I'm calling them by reference over here. Now what if I capture them by value? we see that we get an error saying that we are trying assignment on a variable which is actually read only, meaning that whenever we capture by value, all these variables become read only, meaning we can only access their values but we cannot actually modify them. So now let's see how it again similar to function 1. In function 2, what will happen is that a will be read only and b will be accessed by reference. So uh, any changes I make to b will actually be reflected, but I cannot make any changes to a. So here I'm calling the second function with a parameter of by passing an argument 100. So we see that initially a and b are 10 and 11, following which in func2 I call it with a parameter of 100. So since a is actually read only, I do not actually make any changes to a. I only use the value of a and the value of c to update the value of b. So b then becomes 10 plus 100, which is 110, and which is being displayed over here. Now similarly over here, if I actually without have passing any parameter, if I try to call this function, let's see what happens. We see that a is not it is actually not captured because it is a no capture default, so we can't actually capture any variables which are not actually being captured by the capture clause. But if I make a local variable within it, it'll work fine. It'll we see that the outer a b values are 10 and 11, and here if whatever value of a I give, only that will be accessed by this function. Now what makes lambda functions a bit more powerful than ordinary functions are the capture clause. So what we can actually do is, let's say since now this results to an expression, what I can actually do is I can pass it as an argument to a function. So let's say within I write a function called call, in which I pass an argument called autof, which will accept func1 or func2 or whichever function you pass in. It also has two local variables called a and b, similar to what we are using within the definition of the function, which is a and b. And then what I'll do is over there I'll call the function f with an argument of 10, and we'll see how the internal variables are actually getting changed. The local variables to that function, the call function, are actually being changed. So what I'm doing here, for the call function, the parameter becomes my lambda expression or lambda function, which I can actually replace with this block of code directly over here. And then what I'll do is I'll call it there, call it within that function in which I'm passing it as an argument to, and let's actually observe whatever changes we can see. Okay, so we come to this statement. Here is just definition and declaration. We come to this statement: a and b's values are getting printed. This a and b belongs to the main function, so it is 10 and 11, which is as initialized. Then what happens is I call the function func1, in which I pass the function itself. So now within this block of code for this function called call, there are two variables a and b, and I call f for 10. As per the definition, uh, 10 will be added to the variables a and b, and 100 will be returned. So cout f of 10 should actually give us 100, which is correct. But which a and b will be actually incremented? Will the a and b local to this function, or will it be the same a and b which was in the main function? We see that after calling the function, because it's a call by reference, capture by reference, a and b, whichever a and b it is, it will actually be incremented. So after calling the function, I print out the internal the values of a and b which are local to this function, and we see that it's still 1 and 2. But after calling the call function, we again print the values of a and b to see that their values were actually initialized, meaning that this lambda function captures these values, and these values, whichever it is capturing, is accessible everywhere that function is passed on to. We see that clearly these variables a and b are local only to the main function. They are defined within the code blocks of this main function. They are not a part of call function. But since we are capturing them in our lambda expression and passing the expression itself to another function, these values can also be manipulated or changed from other functions as well. So this is one interesting thing about lambda expressions. So in this video, we covered lambda expressions, what their syntax are, how they are used, and some specific information about them. So thank you.